So we were discussing about arrays, and in my previous Java tutorial I taught you about the sorting technique in Java, right? And in this video I will be talking about the searching technique in Java programming. So let's go get started. Oops, did I forget something? Yeah, the intro. So hey guys, my name is Teja and you're watching TechRod's YouTube channel. In this video, we will learn about the searching technique in Java. So let's get started. Alright, so firstly let me tell you the theoretical definition of searching. So the definition goes like, searching is a process in which you check whether a specific element exists in an array or not. Whatever the array might be, it might be an integer type array, it might be a character type array, whatever the data type of that array might be. So this is the definition, the theoretical definition of searching technique in Java. And yes, of course, theory doesn't make any sense if you fail to apply it practically. So let's go ahead and let's learn practically how this searching works and what for you need searching, and how do you implement, or how do you code, how do you write a program which does this searching technique, and what are the different types of searching in Java programming. So let's go do this. So firstly, let's say you have an array. Let's say you have an array like this, and of course this is an integer type array, and it contains 5 elements, as you could see. The first element, which is present in the 0th position, is 2, and then in the first position there is a number 5, in the second position there is 1, in the third position there is 3, and in the fourth position, that is in the last position, there is 9. So now let's say the user or the programmer wants to check whether a number 3 is present in this array or not. So of course, whenever as soon as I've told you whether, as soon as I've asked you whether 3 is present in the array or not, you will reply. You will say yes, 3 is present in this integer data type array. But computers don't understand like this. We need to do something different in order to make computer understand what we want to do. So that is why we write a code, and we use this searching technique in order to find whether a specific element exists in that particular array or not. So this is why we use searching. And if you ask me to link up searching with some of the real-time applications on the internet, yeah, you all are aware of Google search. So of course this searching in Java is a lot simpler, and Google search is of course a lot more complex. So of course it's similar. The Google search is actually similar. Like whenever you type in something, like let's say you want to learn Java, so you open the Google search and you type in learn Java, and when you search that, when you type in learn Java, and when you hit on your enter button, or when you click on the search button, what Google does is it's going to take that those keywords, and it's going to check in its database, and all the results which are related to those keywords are going to be listed out there. And the same is the process here. Of course it's a simple process here. In this case we are having an array, but in the case of Google it's going to search in the database but not the array. But here we are going to discuss about the array. So this is a simple real-time application of searching in Java. Of course the Google search is a lot complex. Don't make mean comments saying that you fool don't know how you fool think that Google search is so simple and blah blah blah. Okay, I'm just linking up things so that you can better understand. You can just better come to an understanding what searching is. And now let's go and let's learn the type of searching in Java. So there are 2 types of searching techniques. The first one is named as a linear search, and the second one is named as a binary search. So let's learn these techniques one by one. Firstly, let's look into this linear search. Let's learn what is this linear search and how this linear search is going to work like. So let's take the same old example that we have taken. So let's say this is the array. This is the 5 element array, and we want to search this element 3. We want to check whether this element 3 is existing in the array or not. So what we do is, in the linear search technique, what we do is we go. So okay, let me write the index numbers. This is at the 0th index, and this is the first index, this is the second index, this is the third index, and this is the fourth index. Okay, and once again, the elements in this array can be anything, you know, these are just some random values that I've taken, but these can be anything. And once again, this technique works for all data types of array, like it might be a string, it might be a double, float, whatever. Okay, so keep that in mind. And in the linear search technique, what we do is, firstly we go to the 0th index of the array. So this is the array, and at the 0th index we have our element 2, right? So what we do is we check the input given by the user. Like, the input given by the user is the number that is to be searched in that array. So let's say the input is 3, okay, in our case. Okay, so we compare 3 to 2. So why 2, you ask? I've told you already, because 2 is the element present at the 0th index. That's why we compare it with the 0th index element. So firstly we compare whether 3 is equal to 2. Okay, so yeah, of course this is not right. 3 is not equal to 2. So since 3 is not equal to 2, what we do is we go to the next element, that is the element present at the first index. The control shifts to the next element, and here in our case the next element which is present at the first index is the number 5. So once again we check this, we check whether 3 is equal to 5 or not. Sorry, this doesn't look like 3, but kindly adjust. Okay, so 3 is not equal to 5. So once again this statement is not satisfied. We know 3 is not equal to 5. Of course, how can it be? So what we do is the control actually shifts to the next position again, because the condition is not satisfied once again. So once it shifts to the next position, the number which is present, or the element which is present at the next position, is 1. And of course 1 is present at the second index, as you could see. And once again it's going to check whether 1 is equal to 3. And since 1 is once again not equal to 3, it's going to shift to the next position. And what is in the next position? Yeah, the number 3, which is at the third index, is present at the next position. So the control goes to the next position, and once again it does the same operation. It checks whether the input given by the user matches with the element present at that index. In this case it's the third index. So here it says 3 is equal to 3. So it just compares whether the input is equal to the element present at that index. And yeah, we all know that 3 is actually equal to 3. So this statement is going to be true, which means that the element is successfully found in the array. So once this is done, once this condition is satisfied, we can be sure that the input given by the user is existing in that particular array. So we can just print out a statement like the element exists, and we can also print out the index number at where the element exists. So we can just print out the element number, which is in this case is 3. 3 is index number where 3 is present. Okay, so we can do like that. So it all depends on you, but this is the general technique of the linear search. And once this condition is satisfied, the control may or may not go to the next index. So it all depends on you. Once again, it depends on the necessity of the programmer. If the programmer wants to terminate the program once the element is successfully found, then he can terminate. But if he want to find if any other index contains the same number which is inputted by the user, then he can go to the next position and he can check like that. And in that way the linear search works like. Alright, enough of this part. Now let's go and let's have some fun with the coding. Let's write a program. Let's write a simple program which does this linear programming. Let's go. Yeah, of course I'm using BlueJ. So if you don't know, BlueJ is the simplest Java editor, very simple, and it's the best way to learn Java if you are a beginner. So go ahead and download BlueJ, and the link will be in the description below. So I'm going to create a new class here. Don't worry about the class name, I'll change it later. Okay, so this is the sample code. Of course you can delete the sample code, Control A and then the backspace, it's going to delete. And now let's start a program class. Let's say the program name as a linear search. Okay, and then let's declare a method as let's say my name, static void Teja. Okay, or test. Okay, and then let's come into the main logic of the program. Let's declare an array. Let's declare an integer type array. Int arr is equal to, let's take the same example. So this is the array which this is the example which we have taken. So let's use the same example here also. So we have declared an array of integer data type. The name of the variable, the name of the array variable is arr, and it contains 5 elements, and those elements are 2, 5, 1, 3 and 9, same as the example we have taken. Okay, and alright, let me import the scanner class, because import java.scanner class is present in the utility package. So let's import the utility package, and let's declare a scanner class. Scanner in is equal to new scanner system.in. And if you are wondering why I am declaring why am I creating a new object of the scanner class, then it's basically to input a value from the user, and you could simply do that by just giving some parameters in the method. Okay, so you can just give some parameters like int a. So int a is the parameter here, and when you run the program, it's going to ask you to fill up the parameter. It's going to ask you to input a value, so that when you input that value is going to be assigned to the variable a. But I like to make things more complex, so I'm doing it in this way. But it's also a bit easier to I declare the scanner class and do stuff like that, because I don't know, that's my personal opinion. So I have declared an object of scanner class, and now let me print out a statement, system.out.println, which is the common print statement that we use in Java. And then we write, let's say, enter the number to be searched. Okay, so what we're doing is we're asking the user to enter the number which he wants to search in that array, in the array arr. So after this print statement, we are going to accept the value from the user. So I'm going to store that value as int k. Let's say k is the variable and k is the input from the user. So I'm going to input this value from the user. I'm going to say in.nextInt. And if you don't know, this statement is actually to input an integer data type value using the scanner class. Okay, this next int is actually the keyword, the Java keyword, Java reserved keyword that we use to input an integer data type value using the scanner class. Okay, remember that. So what we're doing here is we are storing the value of k, and what value are we storing in k? Yeah, the input that is given by the user, we are storing into the variable k. And next, of course, we want to use a for loop here. Of course, we have to. There's no other possibility in which we can do this thing. So I'm using a for loop. Let's say for int I is equal to 0. So it runs from I is equal to 0. I less than arr dot length I plus plus. So what I hope you're all aware of this for loop. I hope you all know how this for loop works like. And if you're not aware of the for loop, if you don't know how the for loop functions and stuff like that, I have a video in where I explained you about the different types of loops in Java. It's a complete explanation. I hope you will completely understand what is meant by this for loop, while loop, do while loop, and what is basically meant by looping in Java. So I have that video on my YouTube channel. You can go and check out the video, and you'll probably find the link to that video in the description below, or in the suggested cards up the top right corner, I guess. Okay, so go check out the video if you don't know about the looping in Java. And the next thing is I'm going to go inside the block, and yeah, I want to explain you a bit about this. I less than arr.length. What this implies is arr.length is, it results in the length of the array. So here the length of the array is not 5. You're wrong, it's 4. Why? Because we know that in Java programming the index is going to be counted from the 0th position. So if you count it from the 0th position, this 2 is going to be in the 0th index, 5 in the first index, 1 in the second index, 3 in the fourth index, so 3 in the third index, and 9 in the fourth index. So how many indexes we have in total? We have 4. So that's why the length of the array is going to be 4. So I hope you understand it. So let's come inside the for loop, and here lies the main technique. So what I would like to do is we want to use an if block. No, before that we want to declare a temporary variable in temp. So please note that I'm using all the integer data type values here, so you might have to keep in mind the hierarchy of data types while writing a program. So keep that in mind. Since I'm using all the integer data types in here, so it doesn't I mean it's not an issue here because I'm using the integer data types for every variable. So I'm declaring a temporary variable named temp, and here I'm storing the value present at the ith index. Right, so what I would like to do is I would like to do ARR closed brackets, and in between the two closed braces you want to give I. So what this does is, in the value temp, which is the temporary variable, the element which is present at the ith index in the array ARR is going to be stored. Let's say it is the first iteration of for loop, and we know that in the first iteration of for loop the value of I is going to be 0, because here, as you can see, we are starting from 0, so it's going to be 0. So when the value of I is equal to 0, the temp value is what? Can you guess? Yes, the temp value is going to be the 0th index of the array, which is in this case 2. So in that way we are taking the values, and the next thing that we would like to do is we would like to compare if. So if k is the input of the user, if k equal to temp, then if k is equal to temp, then what we know is that the inputted value is existing in the array. So we can happily print out a print statement saying that element found in the array, and yeah, we could as well describe the index at which the element is present. So I can just say at plus I plus index. Okay, this is probably going to also display the at which index the element is present. Okay, all right, and so that's basically that is the basic logic of this linear search. Let's run the program. Let's compile the program. Yeah, no syntax errors. So let's run the program. Just right click and select the method name, which is in case the test. Just select it, and here it asks enter the number to be searched. Let's enter the number 3, and there we go. Element found in the array at the third index. So just like as we have seen in this example, the element 3 is present at the third index, just like as I've explained you. So that's the exact result that is yielded by the program. So this is how the linear search works like. So we humans lack patience. We want to do things that go really fast, and that's why after this linear search technique is invented or discovered, a new search technique came into act, which is called as the binary search. And this binary search is a lot more faster than the linear search. So of course the definition, the searching definition is common in both of these techniques, but there is only some difference in the logic. There is only some difference in the way we check for the element whether it exists in the array or not. So this binary search is a lot more faster than the linear search, and that's why we prefer binary search to linear search. Okay, now once again let's go and let's look upon this binary search. Let's feel this binary search. Let's see how this binary search works and what is the logic that we use to search elements using the binary search. So here let's take an example. So let's take, this is an array, and as you can see, this array is bit more longer than the array that we have considered in the previous example, right? So I'll be telling you why I have taken this array to be of more length than the previous one. It's because I've taken more length array because it would be convenient for me to explain you how this binary searching works like. Okay, so if you could notice one thing, so these are the elements present at the in the array, and there are 7 elements totally in the array, and the first element is 1, and then 7, 11, 23, 39, 43, 56. So 7 elements in the array. If you could notice one thing carefully in this array, you can find something, right? Guess what? Yes, the elements of this array are arranged in the ascending order. That is, the smallest numbers are arranged first and then came the large numbers, okay? So this array is arranged in ascending order, and this is not a coincidence. I have arranged the elements like this purposefully. Why, you ask? Because there is one limitation for this binary search. That is, this binary search can't happen, or it won't work simply if the elements of the array are not sorted. So in order for a binary search to work, the elements must be arranged either in ascending order or in descending order. Okay, so in this case I am doing the ascending order thing because I'm more used to it. Okay, so you can even arrange the elements in the descending order or in the ascending order, it don't matter. Just make sure that the elements are sorted, okay, in a specific way. And how this binary search technique works is I'm going to explain you. So at the top of the array I have written the index numbers. The index numbers range from 0 to 6. Okay, so let's say the value inputted by the user is 7. Okay, 7 is the value which is to be searched in the array, right? So how do you search this array for the element 7 using the binary search technique? Let's learn it. Okay, so firstly what we do in this binary search technique is, as you could see, firstly let's notice the index numbers range from 0 to 6. So what we do firstly is we are going to take the first index number, which is 0 in this case, and then we are going to add the last index number, which is 6 in this case. Okay, so and then we are going to divide this whole thing by 2. And yes, I hope you're good at math, and this is going to give a result 3, right? So we have got a result 3. So what we have to do when we got the result is we have to go to the index which we get here. So in this case I've got 3, so I'm going to go to the third index. I'm going to fix this as my mid term. Okay, the mid term. So once we got our midterm here, what we have to do is we have to check the inputted value of the user with the element which is present at the mid term. That is, in our case, the element present at the third index. So the element present at the third index is 23 here. So we have to check whether 23, which is the element present at the mid position of the array, whether it is equal to the inputted value by the user, which in this case is 7. Okay, the user wants to check whether this 7 exists in the array or not, and we are making use of the binary search to do that. So 23 is equal to 7, is it? No, it's not. It's not equal to 7. So wait. In the linear search, what we have done is, when this condition is not satisfied, when the inputted value is not equal to the element present at that particular index, what we did is we shifted to the next position. Like if you use that same technique here, well, it makes sense that this condition is not satisfied. So if you make use of the linear search, we are going to shift to the next position, that is the element present at the fourth index, which is 39. But this is binary search, and I've told you that it is comparatively faster than linear search, so we are not going to do that because that is a bit of time consuming, So what we're going to do is, well, we know that these elements are sorted out in ascending order, right? So the input value is 7, and the element present at the mid index is 23. So is 7 greater than 23 or is 7 less than 23? We know that 7 is less than 23, right? Yeah, of course 7 is less than 23. So which means that all the elements present at the left side of the 23 are less than 23. Why? Because I've told you earlier that this is in the ascending order. So all the small numbers comes first and the big numbers comes next. So 23, the left side of 23, all the numbers or all the elements are going to be lesser than 23. We know that. So since this 7 is also less than 23, if at all the 7 exists in the array, then it should exist to the left side of the 23. So we can say that for sure, because this is in the ascending order. All the elements are sorted in the ascending order, right? So since we know that this is going to be in the left side of the 23, we can remove, or we can just don't mind about all the terms to the right side of 23, or we can even take out 23, because 23 is not equal to 7, so we can just eliminate everything from 23. Alright, in this case we can just eliminate 23, 39, 43 and 56. We can just eliminate all of those. Okay, so let's consider only this 0 and 1 and 2 index values. Okay, so here what you have to do is you have to search through these 3 index values, and this time it's not linear search, I'm telling you again. So if in the linear search, if you want to search these 3, and if you use the linear search, what we will be doing is we'll be going to the the 0th index, we'll be checking, and if the condition is not satisfied, we'll be going to the next index, and like that. But we are not going to do that thing now, because our policy is to use the binary search now. So what we have to do is we will use the same technique once again. Okay, so once we eliminate all the array from the 3rd index, which is the mid index, we are going to have 0, 7 and 11. Okay, so let me write it separately. So I have eliminated all the other values, and all I have now is the first 3 elements of the array. Okay, so 1, 7 and 11 are the elements, and 0, 1, 2 are their index numbers respectively. So once again we use the binary search, and in here the first index is 0. Okay, and then as I've told you before, you have to take the first index and then add it to the last index, which is 2 in this case, and then divide them by 2, right? So 0 plus 2 is 2, and 2 by 2 is 1. So our result is 1 here, right? So since we have gotten 1 here, we'll go to the first index. This is the first index, and we will fix this as the midterm now. Okay, so now our first index is the midterm, and similarly as we did before, we are going to compare the inputted value with the index, or with the element present at the first index, or simply the element present at the mid index. Okay, so what is the value inputted by the user? It's 7, right? So we're going to check if 7 is equal to the element present at the first index, which is once again 7. Yeah, and of course 7 is equal to 7. This is a correct statement, and since this is a correct statement, we can say that the search is successful, and we can assure that that element is present in the in that specific array. And remember, we have done this using binary search. We improved a lot because we did this comparatively faster, because binary search is comparatively faster than the linear search. So this is how the binary search is gonna work like. So now let's go and let's write a program which does this binary search thing, and which searches the inputted value with the elements present in the array using the binary search technique. So let's go and skip to BlueJ and let's write a program. So I'm creating a new class here, and I'm going to name the class as binary search. Okay, and then I'm declaring a variable. Let's declare a static variable, and let's name the variable as let's name the method as test. And here let me also import the util package, so that I can import the value from the user using the scanner class. So I have imported the utility package, and I'm creating an object of the scanner class. So I'm just saying scanner in is equal to new scanner system dot in. Sorry. So this in here is actually an object name, and you can give here whatever you want. Okay, and all right, now let's create a new array, integer data type array, and let's give the values 1, 7, 11, let's say 36, 39, 41, 56. So let's say these are the values. Okay, so there are totally 7 elements in this array named ARR. As you could see, 1, 7, 11, 36, 39, 41 and 56. So these are the 7 elements that are present in this array, and the length of the array is 6. Yes, because the index is going to be counted from the 0th position. Okay, so right next to it I'm going to declare a variable L, and I'm going to say int L is equal to ARR dot length. So this is going to result in the length of the array, so which in our case is going to be 6. So we know in beforehand that the length of the array ARR is 6, but in some cases where the array where we don't know the length of the array, we can use this function ARR.length, which results or which returns the value of the length of that specific array. So the next thing is I'm going to declare 3 variables: int first, and then int last, and then int mid. So this int first is actually to store the first index number, the int last is to store the last index number, and the int mid is what we use to store the mid number, that is first plus last by 2. Okay, so let's initialize each of them. Let's say first equal to 0. So I'm just initializing first equal to 0, and last is nothing but it's equal to the length of the array, which is L, right? So last equal to L, and mid, let's do it later. All right, now let me input the value from the user. Let's say system.println, enter the element to be searched. Okay, so I'm just importing the value or inputting the value from the user. So I'm going to say int a is equal to next int. So what this does is it's going to input the value from the user, and it's going to store that value in the variable named a. So that variable is once again in the integer data type. So once again, keep the hierarchy of data types in your mind before doing this. All right, now let's start while loop. Let's say while last is greater than first. Okay, so I'm saying while last is greater than first, so which means that this while loop is going to be executed until and unless last is not equal to first. So keep that in mind. Now I'm starting this while loop, and alright, so inside this while loop I'm going to write something like mid equal to first plus last divided by 2. So what I'm doing is I'm just calculating the value of the middle index, which is first index plus last index divided by 2, as I've explained you earlier. So I'm going to have the value of mid now. Now I'm going to check whether the inputted value is equal to the element present at the mid index. So I'm going to write an if block here. I'm going to say if ARR of mid equal to the inputted value, which is a, then we can print out simply and happily that the element is present in the array at mid index. Okay, you got it. Next, what you have to do is, if in case this the inputted value is not equal to the element which is present at the mid index, then we have to do something else, right? So let me start else block here, and inside this else block let me start another if block. Let's say if k is less than ARR of mid, then when we get to know that the inputted value, sorry, this is a here, not k. Yeah, I'm a little bit confused. Anyway, so when we know that the input value is less than the element present at the middle index, what we can say is that the element to be searched, if present in the array, will exist only to the left side of the array, as I've explained you earlier. So I'm going to write it programmatically like this. I'm going to say last equal to mid minus 1. Did you get me? Yes? So since we are eliminating all the elements present from the right of the middle index and also the middle index element as well, we can say that the length of the new array is now equal to mid minus 1, and that value we are storing in the last variable. And there might be another chance. There might be like if a is greater than ARR of mid, and this time I guess you are you know what to write here. Yes, you have to write first equal to mid plus 1. Simple. It's that simple. Okay, so that's it. And out of this while loop, you can just give another if block. You can say if first equal to last, then you can once again print out a statement saying that the element is found at first index. Okay, all right. Okay, so let me compile the program and let me show you the result. Let's see whether it's yielding a good result. All right, there's what is expected here. All right, my bad. Okay, it says the class compiled and there are no syntax errors. Let's run the program and let's try to search for 11. Yeah, 11 is present at the tooth index. Is it true? Is 11 really present at the second index? Yeah, so 11 is present in the second index. This is 0th index, this is the first index, and this is the second index. So which means our program is yielding good results, and yeah, this logic is correct and we have done it right. And one more thing that you have to keep in your mind is that this binary search only works if the data is sorted, if the elements of the array are sorted either in ascending or in descending order. So you can actually write a program, you can actually combine two programs, like one program to sort the elements of an array either in ascending or descending order, and then search for an element using the binary search technique. And you can just merge those two programs and you can just write a single program, so that even if the array is not in the sorted in a sorted manner, the program automatically converts the array into a sorted manner and it does the binary search logic. So in this video, due to some shortage of time, I'm not showing you how to do the sorting of arrays in sorting of elements in the array, but you can check out that program in my blog post. So my blog post will be in the description below. Go check the description below and you will find the written tutorial about this, where you will find a lot of information about this tutorial, and you will also find the program to sort the elements of an array either in descending or in ascending order. So that's it for this video, guys. I hope you understood this, and if you like this video, don't forget to leave a thumbs up below. And if you have any doubts regarding this, you can feel free to leave a comment below, and please do subscribe to my channel for more videos, for more Java tutorials, and also visit my blog at blog.techraj156.com for more written tutorials on Java programming. And that's it. Thanks for watching. Cheers. Hit the subscribe button for more videos. Like my Facebook page at facebook.com/techraj156. Follow me on Twitter at twitter.com/techraj156. Visit my website at techraj156.com. Thanks for watching. Cheers.